A very warm good morning to everyone who are all attending today's seminar. Let us begin this event with an invocation.
जौरतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनामविभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
I'm extremely thrilled and happy to welcome you all for this seminar entitled Women in STEM, a Global Perspective, organized by Physics Department of DG Vaishnav College, Chennai, to commemorate the International Day of Women and Girls in Science. I also want to extend my welcome to our respected principal and honorable secretary for joining with us in this event. Finally, and importantly, I'm very glad to welcome our two special speakers of today's event, Dr. Priya Hasan ma'am, Assistant Professor of Physics in Maulana Azad National Urdu University, India, and Dr. Margaret Bose, Guest Lecturer in University of Lagos, Nigeria. Now, let us briefly know about our two special speakers of today's event. To begin with, I would like to introduce our first speaker of this event, Dr. Priya Hasan ma'am. Dr. Priya Hasan had pursued an integrated master in physics at Moscow State University, Russia. Then she completed her PhD in astronomy in Osmania University, Hyderabad. In 2006, she did an Indo-French postdoctoral project at the Inter-University Center for Astronomy and Astrophysics in Pune, India. Being a polyglot, she is fluent in English, Urdu, Hindi, and Russian. She was honored by the Women Scientist Award by DST, that is, Department of Science and Technology, in 2006. She has presented her work in various conferences in India, Europe, US, and the United Nations, Vienna. Ultimately, she was invited under International Visitor Leadership Program by the US Consulate, Hyderabad, to visit and interact with American universities and research centers. She has been a member of IAPT, African Astronomical Society, and OSWD, Organization for Women in Science for the Developing World. She had a great interest in research field, especially in the field of star formation, astronomy, star clusters, and galaxies. She is actively involved in Olympiads, public outreach, and science popularization programs for students and adults in all over the world. She has worked on various projects with IAU, International Astronomy Union. She worked as DST Women Scientist in Osmania University from 2006 to 2009. She is the co-chairperson of the Women in Astronomy Working Group of IAU and member of ISTD, Indian Society for Training and Developments of the 30-meter telescope. Currently, she is working as an assistant professor of physics in Maulana Azad National Urdu University, Hyderabad, India. We are extremely proud and blessed to have your presence here, ma'am. Now, I invite Dr. Priya Hasan ma'am to give lecture on the topic Women in Astronomy.
Thank you so much, Shweta. Thank you, Shweta, for your kind introduction. And thank you very much to Uttara ma'am and the college, DGVC College, for having invited me to give this talk. I'm very happy to do so. And especially because, like Shweta mentioned, I am with the, I'm the co-chair for the International Astronomical Union, Women in Astronomy Working Group. And therefore, I'm very keen on actually talking to students about astronomy and how women can actually pursue a career in astronomy, right? So I hope you can see my screen. Ma'am, can you see my screen?
I think screen will come now.
Yeah, 1 second. Can you see my screen? Okay. Okay, it's not yet shown.
We are making the screen visible.
So I think you can see my screen now, right?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, yeah. So thank you very much once again. And we'll be talking about today about women astronomers, and which we've titled as She Sees Stars. And I'll basically talk to you a little bit about women in astronomy. Who are the women astronomers whom we are unaware of abroad, globally, as well as in India? And some of the issues that women do face in taking up careers in astronomy. And please do keep your questions. You can either ask me while I speak or afterwards, as you wish, depending on how urgent your question is. So, the event which we are having today is in commemoration of the International Day for Women in STEM, in science, women and girls in STEM. And therefore, I'd like to first show you a short video, which is some.
I introduce this present. Now we're building a detector module. For this, we need to go into the key.
Ihr wollt wissen, was mich an der Wissenschaft begeistert?
Ich liebe es zu rätseln und Probleme zu lösen. Und im Grunde ist es genau das, was man als Wissenschaftler jeden Tag tut.
The great thing about being a scientist is that you always have fun while working. Your work is like your hobby.
We all agree that our everyday highlight in science is teamwork. Let's go to the labs.
So oder so, es macht eine Menge Spaß.
Wissenschaftlerin zu sein bedeutet, beharrlich und zielstrebig zu sein, aber genauso kreativ und neugierig.
Feed your curiosity, you get inspired, and last but not least, you get to know amazing people around the world.
No matter where you are, science extends your horizon to the whole world, in fact, to the whole universe.
Science will shape you and take you to great places.
I wish you all a happy International Day of Women and Girls in Science.
Yeah. So, like I mentioned, this is to wish you all a happy day of women and girls in science. And that's what we are all going to talk about. And what you saw in the video, which was very interesting, is that a lot of women are scientists. and they do live very normal kind of lives. While they do their science, they pursue their careers, they have normal lives, and they enjoy their work, which you saw in the video. Now we'd start about, I'll be focusing on astronomy because that's my subject. So this is a very beautiful picture taken by Dorje and Chuk. This is at Hanley, where India has an observatory, a 2-meter telescope. And this is him, Dorje himself, looking at the sky. You can see how beautiful the sky is. And we've been always looking at the sky and wondering how did it all start, right? That's what astronomy is all about, looking at the stars and wondering how did it all start. What we do in astronomy is we're basically looking for patterns. These are patterns you can see over here, which are patterns in space, but you could also have patterns in time. And the simplest pattern that we see in time is the pattern of day and night, right? You know that the sun rises in a direction which we call the east, sets in a direction which we call west, and this day-night separation is about approximately 12 hours, right? Now, obviously, when people observe this, the question was, why does this happen, right? And in mythology, we had stories of sun sitting in a chariot, where the sun rises in the east, sets in the west, and then the sun gets tired, rests for some time in the night, and then comes back again in the day, right? But we know that actually the reason is that you basically have the earth going around the sun, and the earth rotates. So while the earth rotates, different parts of the earth have the day, and some parts have the night, which actually causes the day and night cycle. And this very small piece of information can be used for various things. For example, here you have a picture of what is called a sundial. A sundial is nothing but a stick. If you put a stick on the ground, right, you can try it out yourself, you will see that if the sun rises, this is the east in the morning, if the sun rises in the east, you'll see the shadow of the stick in the west. And then as the sun sets in the west, you'll see the shadow move to the east. And this can be used to make a very simple clock. Okay, so this is a sundial where you can actually make a clock and measure time of the day. So you'll have the sun rising over here, then you'll have the shadow becoming shorter, and then again the shadow becoming longer as the sun is going to set. As people looked at the stars, they also realized that the sun rises at different constellations through the year, right? So, for example, if the earth is over here and the earth looks, for example, at the sun in December, you'll see the sun in the Sagittarius constellation. While if you were, for example, looking at the sun sometime in May, right, you will basically see the sun in Taurus or in Aries, that's in summer. And people realize that the presence of the sun in different constellations is indicative of the seasons, right? Now, the seasons were very important because seasons, specifically cultures like India, where we are agricultural civilizations, we obviously need to know what is the season so that you need to know when you plant your crop, right? And based on this, we also made calendars, right? So calendars were made based on seeing what is the position of the sun, how does it appear, and in some calendars, you also use the moon, the lunar calendars, which are used in Islamic calendars. You have the solar calendars, which are Persian calendars. And then there are some more calendars, which are a combination of the sun and the moon. For example, the Hindu calendar, the Chinese calendar, the Hebrew calendar. These all are based on this thing. So this basically shows how there's a very strong connect between the stars and human life itself, because we have been actually building our lives based on the observations of the stars. And to mark important events in our calendars, we basically had days which are called festivals. And these festivals essentially mark important points of the season. For example, the festival of Holi, which will come very soon, it is the beginning of summer, right? And with this, the farmer also knows how to plant his crop, and we know that there's a change in season, that now it's going to be warm. And that's why in the Holi festival, people can play with color as well as with water. Similarly, there are festivals which mark winter and different times of the year, which are very strongly related to human life. Now, as we look at the stars, you can see that if you look at the stars from a certain part of the sky, you'll see they rise and they set, right? And there's a point in the sky where you see there is no rising and setting, right? And this is exactly where is the pole star. So the axis of the Earth's rotation is along this direction, which is the pole star. So you'll see stars rising and setting, and you can identify the pole star. And typically, the latitude of your place is going to be the height of the pole star. So if you for your given place, you need to know what is your latitude, and that's at which you can find the pole star. Planets, on the other hand, have a slightly different motion. They have a kind of a loopy motion. They move ahead and they go behind, which is retrograde motion, which is actually why planets are called planets or wanderers. Stars have a fixed position in the sky, but planets move back and forth, and that is used as an explanation of their orbits. And based on this, Aristotle and Ptolemy, they set up what was called the geocentric model. Okay, and the geocentric model was that the Earth is the center of the universe, and you have the stars and everything else which moves around it. And this was a kind of an obvious model because what they saw was that the Earth was stationary and everything seems to be going around us, the stars and the sun and the planets, etc. Right? And but later on, the geocentric model was further revised to what is called the heliocentric model by Copernicus, whom you see over here. And Copernicus actually came a very brilliant idea that if you remember, I told you that planets seem to move back and forth. This is called epicycles or a motion of the planets where they move back and forth. And what Copernicus realized is that if you actually, instead of having a geocentric model, if we move to a heliocentric model, where the sun is the center of the universe and the earth is going around the sun, then you could have planets going around in their own orbits. And for example, if this is the earth, say this is Jupiter, for example, there could be points when Jupiter moves this direction, and when the earth comes here, Jupiter may be moving in the opposite direction. So this can be the planetary motion could be very well explained using the heliocentric model. Another thing here you can see this is Galileo. Galileo observed that Venus, for example, shows phases, okay, exactly like that of the moon. So if you look at Venus through a telescope, you will see a crescent moon Venus, a half Venus, a full Venus, right, which is indicative of the fact that the Venus's orbit is within the Earth's orbit. And therefore, as the Earth is going around the sun, depending upon how much of light falls on Venus, we will see Venus in different phases, right? And so therefore, we apply in science what is called the Occam's razor. Occam's razor is a very simple principle that supposing for a given observation, you have a simpler explanation which takes the fewest assumptions, then that explanation is the one that you should accept. And that was the basic foundation for why the heliocentric model is more important and needs to be accepted, because in the heliocentric model you have minimum assumptions and you can explain the orbits of planets without any problems. But if you have the geocentric model, it becomes far more complicated because planets have these loopy orbits which cannot be well explained. So looking at the stars has always been very beneficial because, for example, like I said, the height of the pole star will give you the latitude of the place. So if this is the pole star, depending on the motion, you can actually find out which is the latitude of the place, as well as you can actually use the stars to navigate in the seas, right? So when navigation was important in the seas in colonial times, in that time in the sea, the only way you could navigate was through the stars. And therefore, sailors also had a good knowledge of astronomy because they needed to find their positions in the sea, right? So like I said, the position of the North Star or the pole star will give you altitude. And you could also use other methods, which is called the longitude problem, of how you can actually measure the longitude of the place. We won't go into details, but we'll keep that in mind. And therefore, using the separation between finding latitudes and longitudes were used for navigation in the sea. And then there was also the development of astrology, right? Which many people, it is one of the most disturbing times when you tell somebody you're an astronomer and they think it means you're an astrologer. And then you say, no, no, no. Astronomy is the study of the universe and things around outside the Earth's atmosphere, while astrology is based on the assumption that the movement of these objects is going to affect your future, right? Which is obviously a totally unscientific assumption, which astronomers obviously do not support. But the importance of astrology is that a lot of funding for astronomy came from astrology, because obviously kings and queens wanted to know what is going to happen to them in the future, and therefore they often had astrologers in their court whose job was basically to look at stars and tell the king as to what's actually happening right? What would they be prepared for? A lot of technology has also been happened because of astronomy. So, for example, films, or even, for example, what we call CCDs. When the Hubble Space Telescope was launched, we needed cameras for imaging and they needed digital cameras. And that's when they actually devised something called CCDs, or what are called charge coupled devices. And the CCD is actually the same technology, which is the one which is there in all our digital cameras, which we use on our phones, on our laptops, and camcorders. A lot of development has also happened in the aerospace sector. We won't talk about it, but amongst the important ones are, for example, GPS, global positioning system, which we basically use in our day-to-day lives, which based on satellite data, which actually tells us accurate positions on the Earth. And a lot of other developments have happened in human life thanks to astronomy. In the energy sector also, for example, batteries, chargeable batteries. These were also devised for the space telescope, and now they are, common features which are there on our phones, on our laptops, on all our devices. There's been a lot of application also of astronomy into medicine, into imaging, as well as into law enforcement and faster travel, various things, right? So we can see that in our day-to-day life also, development in astronomy has affected us, for example, in our smartphones and GPS and navigation, etc. Interesting to know that even memory foam, which you have on your beds, was actually developed for space technology. Now, so passing on science to the masses is very, very important. And astronomy is a very good tool because astronomy uses all the principles in science, right? It uses physics, chemistry, biology, all the basic branches of science. There's application of it in astronomy. So it's often called the mother of all sciences. And astronomy is therefore a very good tool with which you can actually teach science to the masses, right? And Shrishti Astronomy is something which I run, where we have a lot of free programs in which we actually do a lot of astronomy education and outreach. So you can have a look at our website and see the things that we do. So now with our present understanding of astronomy, we know our place in the universe. So what is our place in the universe? We know that the Earth goes around the sun. There are a set of 8 planets which go around the sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And Pluto is out of this thing for certain reasons. But these planets go around the sun. And around the sun, you also have what is called the Oort cloud, the Kuiper belt, from which we have a lot of comets, etc., which visit us time to time. Now, the sun is one of the stars which make up our galaxy, which is called the Milky Way. Now, the Milky Way has a size of about 100,000 light years. I'll tell you what a light year is in a minute. And the Milky Way is part of what is called a local group of galaxies. There's a group of galaxies which go around the Milky Way, which are around the Milky Way. And this also includes our neighboring closest galaxy, which is Andromeda Galaxy, M31, and the Triangulum Galaxy, which is M33. And you have a whole lot of regions which make up the universe, which has a size of about 13.7 billion light years, right? So that is our picture of the universe, which has developed thanks to astronomy. Now, what about women in astronomy? Women have also been involved in astronomy because astronomy has intrigued everybody, right? So, but many of them are unsung heroes. So let's talk about some of them. And what about women doing science? So can actually women do science, right? This is a question which it's more a question which is there in society, right? If you see in society, when women actually study science, people often ask this question, and as to whether women can actually do science. But there are women astronomers who have actually made history, right? You have all these set of astronomers whom I'm going to talk to you about, and I'll tell you how their contributions in astronomy have been so very important to the development of astronomy. And then back home, we have ISRO, and you have these beautiful pictures of women in ISRO who've been actually doing a lot of work in space science, who have been leading teams for various missions, for the Chandrayaan mission, for the Mangalyaan mission, for the Gaganyaan mission. You have a lot of women playing very key roles in these missions. And what about them, right? So let's first of all start about with the women I showed you in the first picture. The earliest known women astronomer is Hypatia, who was a philosopher, astronomer, mathematician. She lived in Alexandria, Egypt, and she's the first female mathematician whose life is reasonably well recorded. But unfortunately, this is her again, Hypatia, for reasons which are unpleasant. Though she was renowned as a great teacher and a wise counselor, she was actually murdered by a mob of Christians because what she thought was supposed to be, what she worked on was considered heresy and it was not considered suitable, right? And that's why she was actually murdered by a mob of Christians. So it actually starts off with the earliest of times, with women facing a lot of, a lot of resistance to their position and their work in science. We'll move much ahead to Mary Somerville, and Mary Somerville is a more recent Scottish scientist, writer, astronomer, and she was actually elected along with Caroline Herschel as the first honorary members of the Royal Astronomical Society. She did various work in astronomy, for example, on studying the magnetizing power of solar rays, on studying the heavens, etc., and various other objects. Caroline Herschel, whom we just spoke about, was the sister of William Herschel, the younger sister of William Herschel, and she was actually the first one who was paid. She was actually paid to do her work in astronomy. She got a stipend of £50 because she worked as the assistant to her brother. So she was the first professional salary ever paid to a woman in England, as well as she was actually awarded a gold medal by the Royal Astronomical Society. She was made a member of the Royal Astronomical Society, and she was also an honorary member of the Royal Irish Society, right? So this was the first paid women astronomer, though, like I said, she basically assisted her brother. And she's actually credited with even the discovery of a comet. This was a comet 34P, Herschel Nicolette, and she discovered not just this comet, but several other comets, right? You also have Maria Mitchell, who was an astronomer, librarian, naturalist, as an educator. She also discovered comets. See, these were the times when people were very interested in seeing comets because they were these fuzzy objects in the sky, which were interesting. And she won a gold medal for her discovery by the King of Denmark. And she was also the first woman to be elected fellow of the American Academy of Arts and Sciences. Okay, so this is in America, the first Maria Mitchell, right? After that, let's move back and move forward in time. You had Margaret Burbidge. She was a fellow of the Royal Society, Astronomical Society. And Margaret Burbidge did very important work in stellar nuclear synthesis. Okay, nuclear synthesis is the study of the origin of elements. Right now, when we study chemistry, unfortunately, we are never ever taught as to how did elements originate, because basically the universe is made up of hydrogen and helium, right? So elements basically originate because there is what is called nuclear synthesis in stars. Okay, stars basically perform what is called nuclear fusion, and when they do nuclear fusion, they fuse hydrogen to produce helium, to produce carbon, to produce all the other heavier elements using these three kind of processes: PP chain, the CNO cycle, and the triple alpha reactions. Now, Margaret Burbidge actually worked with Geoffrey Burbidge, her husband, and William Fowler and Fred Hoyle at the University of Cambridge. And the work she did was considered very, very important, for which Fowler, who was the lead in their work, he was actually awarded the Nobel Prize. But it was very unfortunate that the Nobel Committee, when they awarded the prize, they did not even mention Burbidge's contribution. Though the work that they did, which was published, obviously Margaret Burbidge was a co-author, she played an important role, but the Nobel Committee was very careful to not even mention her name or even acknowledge her contribution to Fowler's work on nuclear synthesis. So you can see that with Hypatia, with Burbidge, etc., from the beginning, there was a certain resistance given by society to acknowledging the contribution of women in astronomy or in sciences. But Burbidge, it's very interesting. You should read her story, read about her life. She actually fought through all the resistance that she faced, and it's very interesting how she continued working through. And finally, she was even made the director of the Royal Greenwich Observatory. Now, for 300 years, this position was always held by a man, and it was never ever given to a woman. And it was generally the Royal Greenwich Observatory director who was also the Royal Astronomer Royal. Okay, and but in this case, when she became the director, they still wanted the Astronomer Royal to be a man, and therefore Astronomer Royal was Martin Ryle, a male, but Burbage was made director of the Greenwich Observatory, a female, right? So Burbage, Margaret Burbage, all through her life, she fought a lot about this thing. And what's more interesting is that she campaigned in this opposition. That, for example, the American Astronomical Society, they had an award given to women astronomers called the Annie Jump Cannon Award. We'll talk in a little while about Annie Jump Cannon also. And but Margaret Burbage declined the award. She very clearly wanted that there should be no discrimination between males and females in the field of science. So therefore, she thought that an award of that kind, which was being given only to a women scientist, which was like reserved for women, actually was indicative of discrimination, right? And therefore, what she did is she refused to take this award because it was specifically for women astronomers. And then 4 years later, she was actually became the first president of the American Astronomical Society. And later on, in 1984, she was given, regardless of gender, the Henry Norris Russell Lecturership, which she accepted. Right. So that's very important. That Margaret Burbage's point of view was that women should fight the battle without any reservations. Right. They should not, because a reservation in a way is also a discrimination, right? So often people, if a woman gets a position or gets an award which is reserved for women, then people say, oh, she got the award because it was reserved for women, or she got a post or a position because it was reserved for women. So Margaret Burbage believed that there should not be any such reservation. Women can fight their battle and win it on merit without having any such reservations. Now, Margaret Burbage continued her work. She worked even for the Hubble Space Telescope, and she developed instruments, did very good things. And like I said, this point of view of hers is something very important, which we definitely need to think about, right? Another very well-known astronomer, woman astronomer, is Vera Rubin. And Vera Rubin, she actually, what's very interesting about Vera Rubin is that Vera Rubin worked on what was called galaxy rotation, okay? We don't have the time today to get into details, but sometime we can. So what happened is, on the observations of galaxy rotations, I don't have a curve over here, I should have put a plot. What people observed is that stars in the outskirts of galaxies, they seem to be moving with very large velocities. Now, the only explanation to this was the existence of what we call dark matter, right? Now, I would say that the most important lesson we need to learn from Vera Rubin was her discovery of dark matter. Now, obviously, you can see that with her times, to actually predict something like dark matter, which did not exist before Vera Rubin's observations, was something very revolutionary, right? If you propose something like dark matter in her times, it was obviously people assumed that there's something wrong with her observations, with her data, that she must have made some mistakes, based on which she predicted the existence of dark matter. But Vera Rubin was very confident about her observations, about her data, as well as her inference about the existence of dark matter. So I think Vera Rubin needs to be looked upon as a revolutionary woman astronomer, where she came up with the concept of dark matter in a time when nobody accepted it or believed it, or had confidence on it. But she stuck to that belief based on her observations and her data. So that is what she used to actually support her observations. There are also a set of women who were called the Harvard computers. Now, the Harvard Observatory, which is located in Boston and Cambridge, and they basically had an observatory where they had very good photographic data, photographic plates with which they were observing stars. Now, they were actually taking spectra of stars which need to be analyzed to very good detail. Now, this was considered a very monotonous job, which was not suitable for men, because men were considered to be doing, more, what would you say, more important work. This was considered to be very mundane kind of work. And but the interesting thing was, the director at that time, Edward Pickering, he hired a set of women who were skilled workers who actually worked on the spectra of stars. And these women are women like Annie Jump Cannon, we just spoke about her, Henrietta Leavitt, Cicely Payne, and Antonia Maury. And this staff actually came to be known as the Harvard astronomers. And these women actually analyzed the spectra which they got at the Harvard Observatory. And this led to very important results. For example, Henrietta Leavitt, she actually studied these spectra and these stars, and there were these variable stars in these spectra, which are called Cepheids, whom she actually found what was called the period luminosity relationship of these Cepheid variables. And these are actually used to find out the distances to galaxies. And many of you all may not be aware. I'll tell you why is that so important. Why was Henrietta Leavitt's discovery so important? So Henrietta Leavitt, like I said, she studied Cepheid variables and the period luminosity law, which could be used to estimate distances to galaxies. Now, what are galaxies? Galaxies are large collections of stars, gas, and dust. They typically have a mass of about 10 power 9 to 10 power 12 times the mass of the sun. They have sizes of about 100,000 light years. Now, what is a light year? A light year is a special unit which we have in astronomy, which is a very large unit. Basically, it is the distance traveled by light in 1 year. And we have this very special unit because distances in astronomy are so large. Now, we know very well is that, for example, if I were to ask you what's the distance between Hyderabad and Chennai, for example, right? It's easier for you to say, oh, it takes like 18 hours by train, right? Because it is easier for us to estimate time compared to distance, right? Now, in astronomy, the fastest moving thing is light, right? And therefore, we talk about the distances traveled by light. For example, we know that the sun is 8 light minutes away from us. That means the light from the sun takes 8 minutes to reach us, right? So which is 150 million kilometers, right? Now, galaxies have much larger sizes. Think about the distance that light travels in a year. So light has a velocity of 3 into 10 power 8 meters per second, and a year has approximately 3 into 10 power 7 seconds. So it would be 3 into 3, which is 9 into 10 power 15 meters. That is approximately, which is a light year. Okay. And a galaxy is huge. It has a size of about 100,000 light years, right? We also have a unit called parsecs, which is 3.26 light years. You have a kiloparsec, which is 1,000 parsecs. And typically size, if you say it in terms of parsecs, it could be about 30 kiloparsecs, for example, the size of our galaxy. Now, Hubble, most of you all must have heard about Edwin Hubble. Edwin Hubble, what he did is he actually observed galaxies, okay? Now, all of you all are aware of what is called the Doppler effect. That means if you have a source of light moving away from you, the wavelength actually gets stretched, right? It moves away from you. It moves towards the redder part of the spectrum, longer wavelengths. If an object is moving towards you, it moves to shorter wavelengths, the bluer part of the spectrum. So therefore, what could happen is you can actually use the spectra of galaxies or stars to find out their velocities. So what Hubble did is he actually looked at the spectra of galaxies and found out their velocities using the Doppler effect. Now, how will he find out the distances to galaxies? For that, he used the work of Henrietta Leavitt, whom we just spoke about, who studied Cepheid variables. And I told you that Cepheid variables can be used to find out the distances to galaxies. So Edwin Hubble came up with his most famous Hubble law because of the contribution, his observations of spectra, as well as the contribution of Henrietta Leavitt. And he came up with this formula, which is V is equal to H naught into D. So the V part was found out by the velocities from the spectra of galaxies, but the D part in his formula came up from the work of Henrietta Leavitt, right? So Henrietta Leavitt plays a very important role in the discovery of Hubble's law. V is equal to H naught into D. And basically, what does that mean? As galaxies are distant away from us, their velocities become larger. So you see this galaxy which is closer to us, the velocity is smaller, while this galaxy which is further away from us, the velocity is larger. So what happens is, as the distance to galaxy increases, the velocity increases, and this is what we call as the expanding universe model, right? That means we know that our universe is expanding thanks to Hubble's law. And with that, which is the speed versus distance, which was found out using the spectra as well as Henrietta Leavitt's this thing, we come up with our important thing, which you must have heard about, the Big Bang theory, right? So if you reverse this in time, there was then the Big Bang, then you have the expansion of the universe taking place as per Hubble's law. But now today we know that in Hubble's law, a very important contributor is Henrietta Leavitt, who gave the distances. We will now move to another Harvard astronomer, who's Annie Jump Cannon. Now, Annie Jump Cannon, she was looking at the spectra of various stars, right, at Harvard Observatory. And used on that, she actually classified the spectra, which is something very, very difficult. You should actually see a picture of the spectra of stars to have an idea. You can see one over here. This is what a spectrum looks like. And you can imagine using these spectrum, she actually classified them and derived a spectral classes O, B, A, F, which are the different spectral classes of stars with which we can actually define the temperatures of stars. Okay, so this was very important work done by Annie Jump Cannon. Okay, using the spectra of stars. So this is approximately what the spectra of stars look like. And you can see these are the O-type stars, the B-type stars, the A-type stars, F, G, this is the sun, similar to the sun spectrum, K and M-type stars. So you can see that this is very, very difficult work. What you get in photographic plate is something like this. You have to then convert it to something like this, which is flux versus wavelength. Wavelength is increasing this way towards the right. And you have to actually make an estimate of the flux as a function of wavelength, get a plot like this, and then use this plot to actually classify spectra. And what Annie Jump Cannon did is she did this spectra for thousands of stars and actually used that to classify. So you can see this is very, very difficult kind of work. And then another Harvard astronomer, Cecilia Payne, she is also one of the Harvard astronomers studying the spectra. And based on this, she wrote her doctoral thesis where she said that stars are basically composed of hydrogen and helium. Okay, this is from the observation of the spectra of stars, which she got from Harvard Observatory, right? And obviously, it took a lot of effort. Initially, her conclusion was rejected, but then it was realized through independent observations that Cecilia Payne was 100% correct, that stars are basically made up of hydrogen and helium. Another very famous woman astronomer is Jocelyn Bell. Jocelyn Bell worked at the University of Cambridge for her PhD, and she was the first one who constructed a radio telescope and found what was, she found what are called pulses, okay? Pulses of emission coming from some object, which was called, people initially thought it was pulses of some kind of alien signal. So they called that the little green men. And later on, it was realized that this was actually from an object which is called a pulsar. Okay. But again, in her case, the Nobel Prize was given to her PhD supervisor, that is Anthony Hewish. And because it was said that she was just the student, but Anthony Hewish deserves the prize because he was the supervisor. And again, Jocelyn Bell was kind of totally ignored by the Nobel Committee. But she's still a visiting professor at the University of Oxford. And 50 years after this, right, she actually won the 3 million Breakthrough Prize. And this is Jocelyn Bell today. And what she's done is she's used her total funding, the 3 million prize, to just fund underrepresented physics students in the UK so that they could actually work in STEM. Andrea Ghez is also an astronomer who just 4 years ago, in 2020, she got the Nobel Prize for the discovery of the supermassive black hole at the center of our galaxy, right? And so you see that globally itself, women have been contributing very strongly to astronomy. In India too, we have a lot of women astronomers. So for example, this is G.C. Anupama, who was the president of the Astronomical Society of India. And she was the former president. Now there's a different president. Then you have Annapurni Subramaniam. She is the director of the Indian Institute of Astrophysics in Bangalore, also a very well-known astronomer, works on star clusters, stellar evolution, galaxies, Magellanic clouds. You have Chanda Jog. Chanda Jog is an Indian astrophysicist who works at the Indian Institute of Science. This is in Bangalore. She works on galaxy dynamics, and she's very well published. And then we should come on to what about ISRO as space scientists? These are the 6 famous ISRO scientists which you should know about. I've just picked up 6. So, for example, there's Lata Ambika, who's the women scientist who's leading the Gaganyaan mission. And she is basically a control systems engineer, basically working with ISRO. And she's the director of Gaganyaan mission. You also have Muttaya Vanita and Ritu Karidar. These 2 women they were heading the Chandrayaan 2 mission and as well as the Mangalyaan and also worked for the Chandrayaan 3 mission. You have Anuradha. She is the senior most women scientist who has been working in ISRO. She basically, since she's senior, she basically worked in the GSAT 12 and GSAT 10 and GeoSat program director at the ISRO Satellite Center. Then you have Nandini Haridnath, who most of you may have heard about it. She was part of the Mangalyaan missions, and she's also the Deputy Operations Director for Mangalyaan mission. Then you have Sita Somasundaram. She is the Program Director for the Space Science Program, and she also was in charge of the AstroSat program. If you've heard about AstroSat, AstroSat was ISRO's first mission of sending a satellite to space, which was basically just made up of astronomy telescopes. Okay, so that was done by Sita. And but the problem is we also need to study about women empowerment in astronomy. So, like I showed you both the pictures, there's been resistance by people to women astronomers, but there have been many women astronomers achieving. And what about women? What is the statistics? So I hope I convinced you that women have actually played a very important role in the development of astronomy. But let us see what about our position. For example, if we see female statistics in the International Astronomical Union, right? If you see earlier in 1930s, 40s, you could see that there were only 10% female members in the International Astronomical Union. Now, the International Astronomical Union is the largest uh, astronomy, committee in the world, right? And you can see it's only about 10% contribution in the 60s, 70s. Now it has further increased, but even now we are like 20%. But if you were to make a breakup in terms of age break, you'll see that in younger generation, you have about a 30-40% contribution of women. Now, why is this problem about women in astronomy, right? If you look at the plot of, say, physics as well as astronomy of women, right, you can see in high school students, you have something like a 45-65 break. That means 45% students are females, 65 physics students are 65% female students are male. We have a very similar picture in astronomy. About 45% in high school, physics students are women, 65% are this thing. Then, as you see, as you go to higher and higher degrees, for example, you go to bachelor's degree, PhD degrees, right? You can see that the number of women drastically falls, right? The number of women you can see has reduced a lot. It's more with physics, little better with astronomy. With astronomy, I think the numbers are a little better. But still, you can see in PhD also less than 25%, less than 20% are women. The rest are all men. And then when it comes to faculty positions, again, assistant professors, associate professors, again, you have lesser women. And full professors, again, you have very few women. So we look at it, for example, here, you can see a better picture. You can see in graduate students, you could have like 65% graduate students means PhD students. About 65% of them could be male, while 35% are female. Postdocs, again, more than 70% are males, only less than 30% are females. Adjunct professors, maybe 75%, assistant professors, maybe 70%, associate, 80% are males. Full professors, you can see 85% seem to be males. Administrator levels also more than 85% are all males. Now, what I showed you earlier, this is what is called the leaking pipe problem. That means at the input stage, there are a good number of, this is also called the scissor diagram. At the input stage, there are a good amount of women. But for some reason, when you come to higher positions, right, then you can see that the number of women has drastically fallen compared to the number of men, right? You can see the number of men are like 80, 90%, while full professor, the number of women are not even 5%, right? It comes down to so much of a level, which you can see in this picture too. If you, this is for just this is called the leaky pipe problem, and you can see that, for example, in the U.S. populations, you can see white females are about 32%, white males are 30 about the same amount, and these are the different contributors in the U.S. population. Now, well, if there was an unbiased contribution, then approximately the same amount of US population should be reflected in the number of people doing science and engineering, right? Because you could say a proportionately similar number of people would be interested in STEM, right? But what you see, very unfortunately, for example, in the US itself, that though white male are barely 32% of the population, but more than half of the people in STEM are white males. And then 20% of them are females. So 70% of them are only whites. You have a decent amount of Asian males and very little Asian females, right? And then these ones are even lesser. So you can see that this problem is a very serious problem, the leaky pipe problem, which I told you. Or, for example, this one, that the people in STEM do not represent the population. So that is the leaky pipe problem. Another very big problem which we have for women in STEM is what is called the two-body problem. Often you have women who are in STEM who are married. You know, their spouses are also from STEM because often they meet their spouses while studying or while working. And when it comes to recruitment, then recruiting people do not want to employ a couple, right? Which is called a two-body problem. They would like to employ only one of the two. And often the male is more senior, he is more, what do you say, more qualified than the female because often he's senior, and then the job goes off to the male and the female doesn't get it. So this is called the two-body problem. And instead, the female, what happens is, by then they may start a family. So the female may be sitting at home, taking care of the house, taking care of children, and which actually gets a big setback to her career, right? Due to which the woman may not actually manage to develop her career as well. So, what are the key issues? How can we actually fight all these problems which women have in joining careers in STEM? So, one big problem is the problem of stereotypes, right? If you might have noticed it that in society itself, if you tell people you want to do a STEM career, right, people would actually tell you, discourage you, right? They would tell you, oh, do something else, don't do that. You can do some teaching, you can do something else, you can, do something which will not disturb the family structure, right? So people actually have stereotypes in their mind where they think women should be doing less challenging jobs, which should be less time consuming, less demanding, so that they can give more time to family, right? So, what are the three-step processes which we need to be doing? One is to educate women, right? You need to educate women, tell them about their possibilities, that they can have a career in STEM, what are the kind of things they can do, what are the interesting things they can do. And like I showed you the video, which I showed you right in the beginning, is that women should not have an impression that if they have a career in STEM, they cannot pursue any other hobbies or they can't do anything else. They have to be educated of all their options, how they can actually do all these things while pursuing their other hobbies too, right? And that there's so much of interesting stuff that can be done in STEM. The other important thing which needs to be done is that at the level of recruitment, right? When people are applying for jobs, they should be equal consideration for women in jobs. For example, the two-body problem I spoke to you about should not exist. Recruitment should be purely on the basis of merit. If a woman is good, then irrespective about whether her husband has a job there or doesn't have a job there, she should get the job, right? Just based on her merit. We are not asking for anything more. We are just saying consider under merit, right? Another important thing is that women do have a problem, is that women often, you start a family, you may have some issues because of children, etc. So employers should actually find ways of retaining their employees. Now, one of the good things which happened of COVID is that people realized that work from home is not a bad option at all. Instead, I think the bulk of companies and places, especially in the private sector, a lot of companies have still, after COVID, they have still kind of retained part of the work from home, mandate. So a lot of private companies have realized that they can save office space and a lot of expenditure if their employees work from home. So, for example, especially like I said, private sector, I know a lot of friends, family who literally go to work maybe once a week or twice a week, and the rest of the day they work from home. Now, earlier people always thought that working from home means you will not work. But nowadays, thanks to the pandemic situation where people actually work from home, people are actually considering the work from home option, and therefore retaining female employees would be possible, can be, some kind of ways can be worked out where these women can work from home if they have issues, for example little children or some other responsibilities. They can actually work from home, they can have more flexible work timings. They could, work in the evenings, work at other hours, as well as to retain their jobs. Otherwise, earlier, many women, if they had problems with their schedules, they were forced to drop their jobs. But now, with this work from home option as well as flexible timings, they can hopefully retain their jobs. As well as they also need to do a lot of gender sensitization. At places, people need to know about how they should behave with their female colleagues, as well as, be sensitized about gender sensitization. So, in the International Astronomical Union, we have a working group which basically works on women in astronomy. This is our chair, Mamta Pomier. I'm the co-chair, and we have a whole set of working group members who actually contribute and actually advise us on how is it that we can help women in astronomy. So we've been working basically on four things. One, about awareness and sustainability, to conduct surveys on working women, on their conditions, on statistical data, so that people are aware about what's happening about them. Another thing I've been very active upon is training and skill building. That means help women develop their skills in technical details, in coding, in various skills, so that they can. We've been conducting regular training programs to build up their skills, etc. We are also trying to work on fundraising programs to raise funds to provide financial support to women researchers in crucial stages of their careers. If they are not into employment, they should be able to get funds for various things. And then another important factor is communication dissemination, to encourage participation of women researchers, setting up communication channels on social media, on seminar series by experts, etc., so that issues can be discussed about and people can actually openly talk about these things. The International Astronomical Union itself has been done various actions to promote women. For example, they still know that the fraction of women in the IAU is low, but you can see that in the IAU, fraction of women in high positions is high. So even the president of the International Astronomical Union, Deborah L. Green, is a woman. And we've had a lot of women in high positions, and they're doing various actions to attract more women, make them more visible, and women can grow into leadership positions, as well as various actions are being done by the International Astronomical Union to increase diversity, right, in all forms, in all kinds of genders. So now if we look at the gender distribution, you can see that even well-developed countries, for example, the United States, the International Astronomical Union, this is 2018, this is old data, you barely had 20% representation of women. You have these countries, Russia and South America, you have these countries where there's 30%, and then only a few places where you could have 40%, right? Greater than 40% gender distribution. So the next IU in 100 years is that astronomy is, we hope it to be more inclusive, more diverse, so that people of various backgrounds can this thing. But this time you have the first General Assembly of the International Astronomical Union, which is going to happen in Africa. It's never happened in Africa. It's going to happen in Cape Town this August. And therefore, a lot of work is being done to promote women doing astronomy. But like I said, though the topic was actually STEM, but many of the issues which women face in astronomy are similar to the kind of issues that women face in STEM careers. And therefore, it kind of applies to all of them. Just as an indicator, this is the General Assembly of the International Astronomical Union in Leiden, which was held in 1928. And you'd be amused to see that these circles are only the female members who attended it. 1, 2, 3, 4, 5, 6. 6 people. That's all females attended the General Assembly in 1928. You can see over here also, the exec committee is only men. Okay. The General Assembly in 1932, you can see that there are few more women, not many men around. Not many women around, lots of men around. And you can see the exec committee also, which you can see a good amount of some women, some this thing. But now what happened in 1988, 1994, you have Ye Shuha, who was the first female vice president from China. And then after that, you've also had much more females over there. So I'd already showed this to you, the gender distribution, this thing, and the various things which are being done by the IAU to promote women. There are, in symposia, etc., you actually check upon how many women are actually presenting. In the General Assembly, you have women astronomy lunches, where we basically discuss issues faced by women in astronomy, as well as a lot of efforts are being done to ensure that women grow in the IAU to leadership positions. So we've had various IAU presidents who have been women. This is the president, who's also a woman. We've had a lot of women and lots of female officers which are there in the IAU. And you can see even the president officers, you have a 2:2 ratio, which is nice. Half women, half men, and lots of women. Division presidents also, you can see a good number of women. In scientific women speaker meetings also, they keep a track about how many women speakers are there. Participants, you check how many women have invited talks and contributed talks to ensure that there's a good representation. Like I mentioned, we have the Women in Astronomy lunches, where women actually can discuss women issues. There's also the International School for Young Astronomers, which obviously ensures that you have a good amount of women participation in that. PhD prizes, this is interesting over here. PhD prizes are given every year in every division in the International Astronomical Union. Again, this is without reservation. This is without reservation. And without reservation, you can see that there are women also winning prizes. They are lesser, but this is far better. This is in the true spirit of Margaret Burbidge, where you have women fighting on merit, right? There's no reserved category for women in this. Gruber, this thing, even for young astronomers, you can see that there are a good amount of women getting these prizes. It's not just men. Though here again, there is no reservation. The IAU also has a women and girls in astronomy session where you actually do various activities and do that. So you can see that there are various efforts being taken to ensure that you have more women in astronomy. And this gender gap which we have, there's a lot of effort being trying to make it, how to measure it, how to reduce it, and how can we actually improve women's representation in STEM, right? This is, I repeat that. And so these are the various efforts. Oh, I'm sorry, I think I looked at this. So I will finally end with this, where what we'd actually work for is a world in which where you have freedom of choice, right? If there are women who would like, I'm not telling everybody to do, do astronomy, but women should have a choice. You have a freedom of choice. You should have equal opportunity. We do not want reservations, right? Without a reservation, a woman should be able to compete, to be able to study, to pursue her career in STEM, where the individual is non-gender, okay? Because reproductive hormones, other than reproductive organs and hormones, we are all equal, right? So let us strive for a world where there is freedom of choice, equal opportunity, and no reservation, where women without reservation can actually fight their battles and pursue their careers. And I'll end with this. This is a quote by Henry Poincaré, which describes the beauty of astronomy. But astronomy is useful because it raises us above ourselves. It's useful because it's grand. It shows us how small is man's body, how great his mind, since his intelligence can embrace the whole of this dazzling immensity, where his body is only an obscure point, and enjoyed silent harmony. And if you notice in this one in Henki Ponka race, you see everything is about a man's body, right? But we hope that this edition of a woman's body also adds on to this, and this very quote can be said in terms of both, right? As man as well as woman. So I'll end with this, and I'd be happy to take some questions. Yeah. So I'd be happy to take some questions if we have some questions. And hello. Hello, Uttara ma'am. Yeah. I'd be happy if you can put your questions on YouTube itself. Then I can check it out on
Chat
YouTube.
box.
And or so obviously I showed you that there's a long way to go. We still have a low representation of women in STEM, and efforts have to be done to increase that representation, right?
Before they start asking, let me just pose this question on behalf of my students. So,
Yeah.
There are many students, who aspire to do astronomy right from their ninth standard itself. So, could you tell us about kind of as students, BSc students, they get to know about the Aries, summer internship. What are the internships that are available in our country? Can you just give some ideas, ma'am?
Yeah. So actually, there are many internships available in the country at various levels. Okay. Now, most of the astronomy institutes, right, which is, for example, Aries, Institute of Astrophysics, Ayuka Pune, NCRA, all of them have summer fellowships for final year BSc or MSc students. Okay. So what happens is you apply for it and you can go and spend the summer over there doing a summer project, right? A lot of it, even INSA also provides, they have a set of mentors, and you can apply to INSA also for fellowships. But these are also all at BSc, MSc level, right? Earlier than that, you can, like you were, since you're talking about school students, right? So even if they, for example, are involved in Olympiads, right? Olympiads is a very good thing for students, school students to participate in, because there's a physics Olympiad and there's an astronomy Olympiad also. So you can apply for that. And if you get selected, they have selection camps in Homi Bhabha Center in Bombay, where they actually train students, and students can actually do projects over there also, right? So, but before that, I better mention that for astronomy, what you basically need to have your focus on is physics and maths, right? So you obviously need to, if you're looking for a career in astronomy, you need to know that you are comfortable with both these subjects, which is basically physics and maths. So, like I said, for school students, you can start off with Olympiads, trying out astronomy Olympiad, physics Olympiad, etc. And then a lot of, in India, a lot of projects can be even done on an informal basis. Okay, in the sense you get in touch with somebody. In most cities, they have planetaria, right? So, for example, the Bangalore Planetarium, they have a REAP program. They have various programs for school students. In Hyderabad, also, the planetarium runs a program for students. I'm not too sure about Chennai, but in most cities, the planetaria, they cover up good programs for school students. So, like I said, Olympiads, you try out the planetaria, and INSA also does some, but I think the INSA ones are also for BSc, MSc level, right? Like I said, all the institutes, all the astronomy institutes in India, you can check up their web pages and apply. So your students who are in final year BSc or in MSc, they can apply for the summer student program over there, right? So yeah. So actually, you need to be checking out their websites on the net. And
That was very useful, ma'am, and actually very exhaustive. You covered many things. And Shweta here wants to know the computer languages that they should learn for a career in astronomy. What are
yeah,
the computer languages?
yeah. So obviously, this has been changing with time, but now it is Python. Now it's full-time Python. You need to be doing Python. That's open source, and a lot of software is available in Python. So that's the one. Yeah.
Sure, ma'am. Thank you so much. So, any other questions, students? Anybody is posting there? So, when we get, we'll send you those questions.
Yeah, sure, sure.
Sure. No. Over to.
Thank you, ma'am, for influential talk. Ma'am, your informative talk on women in astronomy is very inspiring, ma'am. And we got the insight of women in astronomy, their works and their contribution to this field. And thank you for pointing out opportunities and key issues, ma'am. I strongly believe this talk will encourage many women and girls to pursue their career in astronomy, ma'am. Thank you for your speech, ma'am. Thank you.
Welcome. Thank you. My pleasure.
There are a few questions right now. I think one from Shankara Narayanan. One second. Ma'am, may I know what are the ideal qualities that a student should possess aspiring to become an astrophysicist?
Okay, so qualities, obviously you need to work very hard, you need to study, you need to do all it. And like I said, in terms of subjects, it has to be physics, maths, computers. These are the three subjects you should be good at and comfortable with. Right. So.
Sure, ma'am. Again, Varsha has asked the same question. What are some programming languages? So you've answered that Python. Yeah. Thank you so much, ma'am. Yeah. Thank you very much. That's a wonderful insight that you have given us. May now invite our principal, Santosh Babu, to say a few words before we move on to the session by our Margaret ma'am.
Yeah.
Very nice. Where I am audible?
Yes, sir. You are audible, sir.
Okay, very nice. I'm very happy to welcome ma'am for our college program, especially the International Day of Women and Girls in Science celebration, which is on 11th February today. Whereas human in collaboration, institutional and civil society partners that aim to promote women and girls in science. So the present scenario, the basic science awareness about the basic science is coming down among the students community, especially when you talk about the input for any higher learning institution. The people opting for basic science is coming down because we in the higher education are not able to tell to the students that we have a lot of opportunity for basic science. Yesterday also, when I was talking to a few schools, the schools are facing problem in getting a good teacher in maths, physics, chemistry. So that is the thing. But actually the feeder for all program, whether it is engineering or whether it is computer science, whatever may be, the feeder program is a basic science, right from first standard to 12th standard. If the student is very strong in physics, if he's strong in mathematics or chemistry, then only he can go for any research or many things. But unfortunately, we are not able to do it at the school level. And in school level also, when they are coming from 10th standard to 11th standard, most of them, they prefer only the commerce, not than the science. But 20 years before, when I was doing my plus 10th in 1984, the first program, A group, will be always be maths, physics, chemistry, biology. And this, most of the students will prefer this group only. But I don't know why this lot of changes is going on. But as far as Dwarakdas Gorandas Vaishnava College is concerned, we are giving more importance to science, especially women. Where you can see in our campus, the women students are given opportunity to explore in various activities conducted by the different colleges they go. And especially from physics department, they are working with the professors and they are presenting papers and they are visiting a lot of exhibitions, part of their curriculum. So that is the thing. So still we are lagging in promoting basic science to the at school level. But as a Vaishnava college, what we started now is we are asking all the government schools and corporation schools to visit our institution. Tomorrow also, 2 of the corporation school is going to come to our institution and we are going to view the science lab and physics lab. Once if the student started visiting the labs, by seeing the equipments and seeing the other things, he will get interest. And once if he started seeing the equipment, they will come to know that why this equipment is used, what is the output of the equipment. Like that they can do, they can analyze, and slowly from the school side to research side and to knowledgeable they will come. So this is the opinion where in Vaishnav College we started doing that. In coming years also we will give more importance for basic science. And today I am very happy to note that Dr. Uttara and his team is able to have a very good lectures from various people, and we can see that 35% of the students in STEM related fields are women, and also despite statistics that close performance of girls and boys in science and mathematics, but the strong gender stereotypes prevail. Many girls are still less encouraged in STEM field. So what we did is we having a own STEM lab in our campus, and we are promoting the science, technology, engineering, and mathematics to the students. And definitely in coming years, this will improve. Always a cycle. Once we have more importance for computer science, most of the people will come for recruiting people in computer science. Now the company what started is they went for the discipline standard. Even the company, IT companies, they are recruiting maths, physics, chemistry people because they have a domain expert on a particular field, and they are recruiting people from commerce. In banking center, you can see that the engineering graduates are becoming a bank managers. So a lot of interdisciplinary and transdisciplinary is coming now. But for all interdisciplinary and transdisciplinary, the basic is the basic science. So we understand that. That's why we are having all these programs for our students. I'm very happy that Dr. Uttara have roped in a lot of speakers for today's program. All the best. Thank you.
Thank you very much, sir. Now we'll move on to the session by Dr. Margaret from University of Lagos, Nigeria. Margaret, ma'am, you can switch on your audio and video.
Okay, good morning.
Good morning. You can switch on your video also, ma'am.
Yes, I have. I don't know why it's not showing. So let me do that. I'm sorry.
But that's okay. If you have connectivity problem, we'll just proceed with this. Can we switch on the PPT, ma'am, for you? Before that, we would like to welcome you, and then we will switch on the PPT for you.
Okay.
Good afternoon, everyone. We have Dr. Margaret Bose Adedokun with us today to commemorate International Day of Women and Girls in Science. She is physics lecturer at the University of Lagos, Nigeria. Dr. Margaret received her degree from the University of Jos, Nigeria. She completed her post-graduation in radiation and health physics from the University of Ibadan. She took up teaching position in the University of Lagos in the Department of Physics. She completed her research in the same university. Her research interest covers aspects of radiation and health physics and medical physics. She currently teaches general physics, modern and nuclear physics courses. She is author of papers in national and international referred journals. She has attended international conferences, workshops, and seminars. She recently represented her country and attended career development workshop hosted by International Center of Theoretical Physics, Trieste, Italy. Here we have a person who balanced her career and family and fought her circumstances to complete her research. Now I would like to invite Dr. Margaret Bose Adedokun to give her talk. Thank you.
Thank you so very much. I wish my camera could come on so you could see my face. I'm also trying to share my slide. I don't know if that is happening.
If you just try to share your slides, Margaret. Otherwise, we have your PPT, so we can also
okay,
share
so
it.
you please share, and then
yes.
you assist. I will have to
Yes,
tell you to the next slide and all that. Thank you.
Not an issue at all.
So first of all, without wasting our time, I really want to thank the organizers. I want to thank the convener for having me today on this special occasion, and to also talk about this special and needful conversation, to be part of this conversation, talking about women in STEM, a global perspective. Next slide, please. I want to also say congratulate all of us on this platform in celebrating the 2024 International Day of Women and Girls in Science. It is very important, and I congratulate us because it's not all women in STEM who are even aware of this International Day celebration. And not all girls in STEM are carried along. In my institution, I confess we haven't done ours. We're thinking maybe later in February we'll be doing that. So I want to congratulate everyone on this platform, and also thank you to our convener and also the organizer for putting this up. Next slide. Next slide, please. Okay. So like I've been rightly introduced, I'm into medical physics. I'm a medical physicist. And the area of medical physics is an applied physics, where we apply the concepts and methods of physics, particularly in medicine, towards prevention of diseases or treatment or diagnosis of diseases. One major area that I think everybody will be aware of is cancer treatment. So with cancer treatment, you have a medical physicist involved. And our involvement is basically because we use the concept of radiation and basically the effect of radiation on biological system. So we know radiation affects biological system, and we use that idea to kill the unwanted cancerous cells. Sometimes medical physics, we have different nomenclature for that. In some climes, it is biomedical physics. In some places, medical biophysics, applied physics in medicine, physics application in medical science, radiological physics, or hospital radio physics. We are saying the same thing. And our basic concept comes from what we know, the physics of radiation, and then we apply. Next slide, please. Next slide, talking about the branches of medical physics. So we have radiation oncology, that's using nuclear processes for cure. For cure, we have the health physics, radiation protection. So this comes, we want to know the causes or potential things that can give us radiological effect. So we look into that, and then the way of stopping, that's the protection aspect. Then the non-ionizing radiation, when you talk about your communication, your radiation from your TV set, from the microwave, is still radiation. So we look at those ones, though they are not ionizing. And then there's a branch of medical physics that is education, of which I belong. And my area of research is the health physics radiation protection area. Let's move on, please. Next slide. Okay. So coming back and focusing on our area of discourse for today, which is women in STEM, global perspective. So some keywords, jump out at us immediately, and we have women. So who are, or what are women? Women are female human beings, simply put. And then what is STEM? I believe Dr. Hasan had spoken about that. She has touched that. And let me say at this point that some of the things I will be talking about will be reiterating the point she has made or making some emphasis. So STEM is, we're talking about science, technology, engineering, and mathematical fields. Anything in this area is what we're considering today. And the global perspective. So when we say global perspective, the view that has global influence. So our topic basically is talking about the female human beings who are in this field of STEM and what is the global perception of them or the fields that they are into. Next slide. Okay. So there are some general perception, and we just want to talk about a few of them. General perception of females relative to men. So when we look at the family, the perception, for a woman is that she plays a supportive role, or she should play a supportive role. A woman is expected to care for children, to cook, to clean, to just do some house, chores. Whereas in the family, the man is expected to take care of that family financially, is expected to work on things like cars around the home, is expected to do some home repairs. Then if you look at traits of a woman or attitude expected to be found in a woman, sometimes they say women are vulnerable, they are weak, they give birth to children, so they need protection. Their attitude should be polite, a woman should be accommodating, a woman is nurturing. Whereas a man is expected to be strong, aggressive, and bold. What about in the area of how you look and how you dress? A woman is expected to be attractive in her looks. She's expected to be feminine in how she carries herself with grace. And not much border is put to the man relative to how he looks or how he dresses. So there's also this expectation in profession for a woman, because she's looked upon as somebody who is soft and nurtures and teaches. So in profession, career-wise, she should be a teacher. She will be good as a nurse. Whereas a man is expected to, or is being told that he's perfect for STEM. A man professionally is expected to be professional, to be successful. If a woman is not so successful, it's okay. She can depend upon on the husband. And the premium that is placed on a man is usually higher, whether in the workplace, sometimes in the family, the expectation, they feel, now I have a male child, I believe that male child will give me this and that. But for a female, the premium is a bit lower. We can move on. So these are some of the general, perception, and sometimes global. Even though, we have general perception, they differ a bit, moving from one ethnic group or one cultural group to another. Next slide, please. And so I want to talk about, just mention a few of these stereotypes, if you choose to call them that are peculiar to Africa. So in Africa, the husband is the head of the home, is meant to protect the woman, and the woman is meant to take instruction and obey from the man. Some of our peculiarity that differentiates or gives, a division between how you see a man and a woman and the things that happen to women is that in Africa and some parts of Africa is becoming better now. You have less of that, but it still exists. That women or girls get married, most of them, or in some areas, most of them get married before the age of 15. And when they get married, often they don't return to school. So they stay back at home, or they do a menial job of cleaning or washing or cooking or assisting in a restaurant because they dropped out of school because of marriage. And this affects economy, because the contribution of the women, because they never went to school, they take lesser job that gives us lesser value in terms of the economy of the society, and they get less, salary. So one other peculiarity for us is that in politics too, it is expected that that's a zone for men, not for a woman. If a woman is seen in politics, we have a few, but the first question could be, where is her husband? Who allowed her to be here? Are you sure she's married? And things like that, which may also be coming even from the women fold. So these are some of the peculiarities. Next slide, please. I think I have a few more. Okay. So some of our, the stereotype or our conception about a woman in Africa is that a woman's education ends in the kitchen, whereas you can put all your effort upon a male child to go to school. For a woman, you say it ends in the kitchen. And this is quite close home. This point is quite close home for me. My mom was not so educated. She only finished primary school, but her brothers are both educated, the two brothers she has. She and one of her sisters, one managed to become a teacher. And the basic thing, the basic notion for her dad then was that a woman's education ends in the kitchen. So these are some of the things, the society puts on a girl child. If you're a boy, why do you want to be a chef? But as a girl, you can play and begin to dramatize being in the kitchen is okay. But for a boy, everybody tells you, you are a boy. No, you don't do that. That stereotype. And for a female, you say you want to go into engineering. They tell you that teaching will afford you more time for your family. Why don't you think of a smaller job, a lower job? Engineering will be too cumbersome. So these are some of the things that, the society and peculiar to Africa, I believe. Next slide, please. Okay, so this is another thing about the value that is placed on gender in Africa. The picture on my left that says no male child. So this is an African woman with 5 female children. And just imagine with me that she's pregnant now. If care is not taken, she's going to end up being in the state of the second picture that says you have another girl. After 5 girls, then the man goes away, looks for another man. You have pressure from everywhere, from his family. Nobody to take on your legacy, nobody to take on your name. So what are you really doing? So we have this value placed on gender. Next slide, please. Okay. So I was just thinking, on the issue of what the society tells us and how much it has actually entered into us ourselves as females, even those of us who are already in STEM. And I thought of this picture. So I'm painting a scenario that I have these 2 wrapped gifts for two professors in my department. So it's an award ceremony or a send forth ceremony or whatever, but we have 2 professors involved and we have wrapped these gifts. So if I'm going to use you as my audience today, what gift would you advise me to give my male professor? And which one will you advise for me to give the female professor, having wrapped them in this nature? I believe the answer often will be that the A wrapped gift should be for the male professor, while the B wrapped in pink, rainbow color is likely going to be, I will likely be advised to give that to the female professor. Okay, let's continue in this ride with me. Next slide, please. Okay, the next slide gives us 2 pictures of a classroom. The one on my left has about 4 rows filled with boys or young men and half filled row with girls. And the second one has, from the picture, we can see only barely about 2-3 boys in the picture, and we have more females. So for you, my audience, my students, my colleagues who are female, what class, which of these classes would you rather be in? And the point I'm trying to make with the pink and the blue and the class that is filled with boys and the one filled with females is that the stereotype, is there, the perception is there, and this perception, societal perception, has become and has become something that has stayed with us. You don't even know what I have wrapped in the gift, but because of that color blue, the suggestion is likely going to be that I give that to a male professor. Then in this class that is filled with male, a lady, a girl may feel intimidated. If possible, if a physics class will look like the one on right, it will make her feel better. because the boys are sometimes bossy, they are sometimes too bold, and they can make you quiet or ignore you in such a class. Next slide, please. Okay, so societal influence. This influence on us choosing pink and us preferring to be where we have more women has become an influence, on the kind of career choices that we make. So because you have been told all you've been told, because the society does what all it does, a female is typically drawn more to fields that fit that image of nurturing and of teaching. On the other hand, boys are taught to be curious and to lead. They are told they are perfect for careers in STEM. And then even though sometimes, they are struggling with mathematics, you have a boy, you just keep encouraging him because you want him to become an engineer or to become a pilot. So the society has, influenced us in some of the things that we do. Next slide, please. Okay, so what are the current realities? We have seen the world's perspective on our gender. We have seen the peculiarity, some of the peculiarities that we have even in Africa. And we have established the fact that somehow, this society, perspective of us sometimes affects the way we do things and even the choices that we have made up to this point. So what are the current realities in STEM? Part of these statistics have been, talked about by the previous speaker, Dr. Hasan, but I'm going to reiterate some and then maybe talk about some in a different light. So the graph I have here gives us an idea of the numbers of researchers that we have in STEM. The red column stands for the women, representation, while the purple gives us a representation of men. So for researchers in STEM, 33%, that's 1:3 ratio are women, while we have obviously more men. And the fact that we have up to 33%, the percentage drops in the representation of women in national science academies. They are lower. When it comes to area of artificial intelligence in the workplace, only 22% are women. Engineering graduates, we have just about 28% relative to men who are 72%. For computer graduates, women are about 40%. And for Nobel Prizes award from, I think, the 1900 to 2013, the representation of women that we have in all of the Nobel Prizes award are just 7.16. And we have a fewer representation. So this is for all the Nobel Prizes, whether it's in arts, humanities, or science, and definitely science portion is much lower. So this is our current reality. Next slide, please. And a typical STEM workplace looks like this. The picture on the left gives us idea of the proportion of women that we have in the workplace. So coming from, you should do engineering courses, you have accepted to do it, you have accepted to stay. When we get to the workplace, we still have, I think this is even a bit moderate and a bit modest because we have 1 out of 5. In my own institution, in my department of physics, University of Lagos, we're just 2 women and we have about 20 men. So this is a better, representation here. And so the picture on the left tells you the height, the level where the men are relative to the women. So the women take the men take the supervisory role, and this is expected because they are more. They take the leadership role while women are there. Sometimes, even when you come together, the pay, the salary is not the same. You take the same job, but a woman is looked upon. A man should earn, more. A man should earn more for whatever reason. You take the same job. And sometimes, men have been taught to be bold. So in their bargaining ability, they are stronger. So this is, like our current reality. Next slide, please. Okay. So I want to pause at this point to talk about my own journey. And like I said, some of the points I'll be making will be reiterating what Dr. Hasan have talked about. Yes, our representation is lower, 1:3, 20% and lower, but we still find women. We have, she talked a lot about women from way back. So it's not a new thing that you have women. So the thing that the society has been talking about can be true to a level, but we still have women, and we have had women from way back. Dr. Hasan is a woman in STEM. The organizer, they are women in STEM. I am also saying I'm a woman in STEM. But how did I, manage to get into it? Having talked about the realities and the stereotype that we have, how women are perceived, having lived in Africa, born in Africa, went to school in Africa, how was I able to navigate all these waters? My parents were not really educated. My mom, primary school. My father never went to school. He tried to teach himself, but they valued education. They believed education was a way, for you to be better in the society. Thank goodness that I had that opportunity. There were people at their level, at their own generation, who still never cared. There were many people at their generation who will say, go to primary school and stop, go and learn an art, and then you continue, especially as a woman. So in primary school, I was there, and my thought in primary school was that I was going to work in the hospital. And my understanding of working in the hospital or in the medical line is that women are nurses, males are doctors. That was my understanding. And I kept on, I was going to become a nurse. Got into secondary school, senior high school, you have to choose whether you want science or art. I chose science because I didn't see how I was going to fit into the art class. And one interesting thing for me, my personal experience, is that in physics class particularly, we were just 4 girls. And we were the only 4 girls who took further mathematics, additional mathematics, as it's being called in some other clients. We were just the only 4. And we were looked upon differently. I think the only thing that kept us, 3 out of the 4 girls wanted to study medicine. 1 wanted to go into engineering. We just thought we knew what we wanted, and then we continued. And then I got to the point of getting into university. I wanted medicine, like I said. But one thing led to the other. I found myself in physics. I tried to come out, well, it just didn't happen. I stayed put in physics. My experience also in being in the physics class, of course, dominated by males, is that as a girl, if I had any question, especially in mathematics, and I asked any male, there was this thing that you are slow in understanding. This thing is this easy, and they just do this and that. You should have gotten it now. Not knowing that most of them were also struggling. I discovered that when results came out. So you see, boys can be bossy, they can be domineering, especially when you are missed them in a class where they dominate. However, I managed to finish first degree. I wanted medicine, like I said before. So I was introduced to biophysics from undergraduate, that's bachelor's level. And when I graduated, I found radiation and health option in physics. And then I went there. And then after that, I continued, discovered medical physics, and I went into medical physics. And I graduated as the first female medical physicist in University of Lagos. So that's my own journey. Next slide, please. That's my own journey. I've gone through STEM like every other girl, like every other woman. And the story for my medical physics is a very serious one, because by the time I was doing my PhD, I was already married, I was beginning to have children, and I had to juggle, but I was able to finish. So what is your own approach? We have established that the society, the workplace, different things happen, but what is your own perspective? It's okay, it's interesting that I'm speaking with those who are already in STEM, but do you feel like leaving? Do you get bullied? Do you get ignored? Will you also say you think STEM is difficult, you are not really sure it's for females? Would you advise your sister to come into STEM? Will you advise your female younger friends to come into STEM, or will you discourage them because of societal influence on you? Next slide, please. Okay. If we allow the society's influence, it will continue with the culture that we have around. If we continue, with status quo, 10% of women in workplace, in a STEM workplace are just women, 10% of the population, women, 90 continue to be men. We don't, in the schools, we have less girls, applying for STEM. If we allow that to continue, then we're still going to have less workforce. Because like the example I shared of Africa, where they drop out, and so they have to stay in the house, they have to stay at home, or they take a job of cleaning up. So we'll have less workforce in the area of STEM, because women are part of the population and they ought to contribute their quota. And talent will not be earnest. Some of us have had, experiences of where we have girls topping classes, difficult physics courses, and you have girls stopping. So we've got that potential. But if we continue to be made quiet as a society wants us to be quiet, talent will not be earnest. The next thing is that we're going to have shortage of mentors in STEM. So imagine you struggling to come into a STEM class or a STEM course, like you're in physics, as the case may be, and maybe you have managed to be two females, and in that class, all of your lecturers, or in that department, they are all males. There are things that are specific to women. There are things that women understand better. So if women would, continue with this STEM, with this field with these fields, then we're going to have more mentors who are women. So we cannot afford to shy or to shrink back. The work environment will continue to be predominantly male if we continue at the rates, or agree for the influence of the society to take over. We'll continue to have more men, and as we have more men, they will definitely continue to take leadership role and supervisory position. If we have men-dominated STEM, it will also be difficult for women to gain entry, because they are used to men. They believe men will do the work better. Men don't have to get pregnant. Men will not have to take care of ladies. So if we continue this way, then it will be more difficult to gain entry, less thrive, or to achieve your potential. So we must do something. Next slide, please. And some of the things that can encourage us here is, I've talked about, we have the convener, we have women amongst them. I'm a woman in STEM. The first speaker is a woman, and she took us through the journey of several other women who are doing well, and those who have done well, who have really contributed. So you are not alone. We may be few, but we have our representation. We are not 0%. We have our representation. So there are people like you in STEM. Encourage yourselves to stay. Encourage others to come. Women are essential to countries' development and functioning. Don't believe what the society is saying that is more for men. We have our ideas, our thoughts, our knowledge is an energy source. There are things that are peculiar to us. Sometimes we're more patient to discover. Sometimes we're more patient to work it out. So let this be a source of energy for us, and let it be a source of us helping, the society to function. Women are driving force behind small changes of critical importance. If you say, yes, the woman, who even nurtures the man? They believe the man must be bold, he must be aggressive, he must be in STEM. Who nurtures? Most times it's the woman, it's the mother who nurtures. So we can't shy away, we can't run away. We have a part to play, we have a contribution, that the world is waiting for. Women are just as capable as men. And when it comes to academic proficiency in STEM, we are still capable. Women are good in mathematics. Women are good in physics. They are good in coding. They are good. Mary Curie, Dr. Hasan also mentioned her. She's a fundamental, she's fundamental to the discovery of radioactivity. This is a woman who worked with her husband. She was just like you and I. She was a normal human being. She was once a girl, but she chose, to face her challenges. She held her bull by the horn, and today we still remember her after she's long gone. So we all have this strength within us. The society may be saying what they are saying. Our employers, we find them in the in the world of STEM the way they are. The government, but we have strength within us. We shouldn't let anything make us quiet. Next slide, please. Okay. So what is the next step? What are we supposed to do? The society has its own. We may want to change the society. We try to talk to them. And the man, pardon me, I've forgotten his name, who spoke after Dr. Hasan, we saw even the effort of men, sometimes the effort of government, trying to say, okay, you are welcome to STEM. We have seen women who have given us example. We have seen the consequences if we don't come into STEM and encourage others to come. So what are the things we're supposed to do, even as we celebrate International Day for Women and Girls 2024? What are the things that we should do? There should be no reason for gender to limit women's career growth. And Dr. Hasan, had mentioned that. And there shouldn't be limits to even limit our choices of the career that we want to, go into. So go for what you want. The female-male ratio should not be a major thing or that would discourage you from choosing your majors or choosing your courses. It should not be a career. It should not be a factor. Be true to yourself. Be unbothered about what others think. Oh, you are not supposed to be there. Oh, you are supposed to be there. Don't bother yourself. Just be true. This is what I think I want. This is where I think my inclinations are. And then just go for it. Then be supportive to others. This is important. So for those of us who are already at the workplace, maybe teaching or anywhere in STEM, let's encourage one another. Let the woman encourage another one. I meet that encouragement. By the time I got to University of Lagos, my department, I met an elderly woman who after a while, she left. Currently, we're just two, like I said before. But there are things that are peculiar to us, and we are the ones who understand our language better. So support somebody. Encourage the girls. If you are teaching, don't frown at them. Understand that they have sometimes peculiar issues that boys don't have. You are in a class conducting exam, a girl is not comfortable. It could be that she's having cramps. It takes you, a female lecturer, a female, to understand that. So please, let's be supportive. Sometimes, I don't know whether that's peculiar to Africa, you hear like charges repel, things like that. So female, they repel one another. No, we should try to support one another. We should take opportunities. There are opportunities for us. The world may be saying whatever they are saying or whatever they think, but there are opportunities that we can take. There are opportunities for women in STEM. There are opportunities for anyone in STEM, but there are those that are peculiar to women in STEM. And we can check them up. They are diverse. We can look into them and, take those opportunities. By the way, the UN, that's the United Nations that is putting the International Day of Celebration for Girls and Women up in STEM. One of their core desire or their aim is that full and equal access, be promoted. They are promoting it, and we also should do that. We should promote full and equal access and participation of women in science. So we should not be seen as those saying it's difficult, don't come in. So let's encourage one another. We know that it is possible. Next slide, please. So the world is waiting for you. Your contribution is unique. Your contribution, your talent is distinct, is unique, and the world is waiting for you. Please do not, discourage or disappoint the world. The world is waiting for you. I am waiting for you. And I know together, as we encourage one another, as women in STEM, we can get there. Thank you very much for listening. Thank you. The last slide says thank you. Can you hear me?
Yes, I can hear you.
Okay, I said the last slide.
Yeah. One second. Yeah. 1 second. It says thank you. Yeah. 1 second. And that was very, very inspiring. And especially, when you spoke about your own journey, that was that made a great impact. Students, you can post your questions and you can start conversation with Margaret ma'am. It'll take few seconds, Margaret. They need to post and then only it comes.
Okay.
So one of the questions is like, why? What inspired you to take medical physics, that particular field?
Okay.
So why did you choose exactly that field?
Okay. So, like I mentioned earlier, I wanted to study medicine. I saw myself as a medical doctor right from, and my siblings could also attest because of the things I was doing as a young child. Though, like I also said that while I was in primary school, I thought for you to be a medical personnel as a female, then you are a nurse. So initially in primary school, I always said I was going to be a nurse. Then my knowledge increased, and by secondary school, I was saying I wanted to be a doctor. I didn't want physics at all, but by third year, I was introduced to biophysics as an elective, and I chose biophysics. And then I found my way in final year into nuclear physics. So I found an application of physics in medicine, and that drew me to that. So basically, that was what channeled my journey. So after my first degree, the second degree in physics, I looked for what was closer to the medical field. And what was available then was radiation and health, which is an area of medical physics, but it's more of radiation protection, how you protect radiation workers against radiation. And then I left that institution and got opportunity of medical physics. And so that was basically my story.
Okay, that's nice, very nice. Getting inspired by biophysics and then you initially want to do medicine. Yeah. Shankar Harini wants to know, ma'am, how well were you mentally prepared while pursuing your dream against all the odds?
Okay.
Emotionally, how well you prepared?
Okay. So my first response was I'm not sure I was mentally prepared.
Okay.
I just think my preparation, came as I went along the path. So let me give you an example of not wanting to study physics. So physics was boring to me at the initial stage. In secondary school, I only studied physics because I needed it for medicine. If it wasn't necessary for medicine, I wouldn't have done physics. But along the line, because I wanted to do medicine, I had to encourage myself. One of my elder brothers said, physics is mathematics. You love biology. Biology is even broad. Why, So he encouraged me that it was possible for me to pass. One of my elder brothers. That it was possible, just keep at it. So I continued. I got into university. And like I was telling you that we were kind of bullied by the boys until our first semester results came out. And we discovered that, we're not doing badly anyways. And though I wanted to leave physics, after first year, I was intending to leave physics. I didn't see any future for myself in physics then. But I told myself, so I don't know whether I was mentally prepared without knowing. I told myself that I was going to leave physics, but it will not be said of me that I failed. That was why I left. So I was ready to still put in my best and get it that way. So I think maybe that's the spontaneous preparation aspect. Maybe the other aspect that is not directly, for physics was how I was brought up. My mom, very hardworking. She involved us in the things that she did in business. So she made us hardworking. Sometimes you had to leave food. Breakfast, you would have walked to a level. And we grew into that knowing that, okay, work, then you can eat. So maybe that kept me when physics seemed quite difficult. So maybe, I don't know if that make sense to you?
Yeah, a lot of sense, and that work hard so that And how did you face the social odds, the social challenges?
Okay.
One is towards physics, the other one the environment and the social challenges. How did you prepare yourself to face it?
Okay.
Or
So the social challenges were still there and are still there, but they are not as heavy as they were at my mother's generation. People are more enlightened now in some areas. You stay in the city. If you go to some villages, some area of Nigeria, is still the same thing. A woman will not take even what do you call it, education, Western education. So it's still there. But at my time, it was a bit lower. But entering physics, nobody in my house wanted me to do physics. Maybe in a way because they also thought I was going to be a medical doctor, and they thought that was better for them. For my father to be
now we
addressed
got
as a
medical
medical
physicist. That's
doctor.
nice.
And I remember one of my younger sisters always saying, physics teacher, and I will always tell her, I'm in physics science, I'm not in physics education. So even my younger sister had a role to play. And I wasn't too proud to tell people I was studying physics. That's the truth. I thought at that point I would have been more confident to say I'm in medicine than in physics. But one way or the other, maybe after first degree, that was when the confidence began to grow. Maybe after first, yes.
Sure, that's great. And I think it is Mr. Samson added, he says, thanks, Margaret. This is your husband supporting you and other women. Thank you so much, sir, for being a great support. Yeah, thank you so much. Thank you very much, Margaret. Yeah, just please hold on.
I'm sorry, I don't know what happened to my camera. I tried it yesterday. This morning it was coming on. I wish you could see my face.
Your voice and the command, that compensated. That's okay. Your slides were beautiful, and then we really enjoyed it. Just a second. Yeah.
Thank you, ma'am, for your table on global influence on career choice and specifying the gender inequality stereotypes in the world. And the situation in Africa on gender inequality you talked about resonates with the situation here, ma'am. And ma'am, your life journey you shared has greatly inspired us, ma'am, and will help us to get through any similar situations. And thank you for today's lecture, ma'am. Thank you.
Thank you so much. I appreciate it.
Good afternoon to everyone. It has been such an honor for me to propose a vote of thanks on behalf of our Department of Physics. I would like to extend my heartfelt gratitude to our today's speakers, Dr. Priya Hasan ma'am and Dr. Margaret Bose Adedokun ma'am. Your talk on astronomy, medical physics, and journey of women in STEM has greatly inspired us, ma'am. Once again, thanks to both of you for making this day memorable. Thank you, ma'am. I would also like to thank our respected Principal Sir and our Honorable Secretary for joining us. My sincere thanks to our Department of Physics for organizing this wonderful event to brighten the future of our students. I am very much thankful to our department head, Dr. D. Uttara Durarajan ma'am, and faculty coordinator, Sangita ma'am, for conducting this event. And special thanks to technical team who helped to carry this program. Once again, I thank everyone who made this event to happen successfully. Thank you.
Thank you all once again on behalf of Department of Physics, DG Vaishnav College, for joining this online seminar on women in STEM. Thank you so much.